So now we have what is next, which is covalent compounds, nonmetals and nonmetals. So let's take these next. So when we talk about covalent compounds, you guys can remind me the definition of covalent compounds? So covalent compounds are made up of what two things? They are made up of non-metal plus a non-metal. Covalent are also called what? Also called molecular compounds, okay? So now guys, the next thing is that we need to talk about is the prefixes, because we know for molecular compound, we need prefixes like mono, di, tri. So guys, the prefix for one is mono, two is di, three is tri, four is tetra, five is penta. Now guys, usually in my class, when we were doing this face-to-face, we expect students to memorize this list. So you can also try to remember them, and that will be beneficial for you when you take later classes. So guys, 6 is hexa, 7 is hepta. This is usually the most confusing one. Hepta and hexa, these are usually very confusing because both start with H. What I'll say to remember is, as you see, hexa has X and 6 has X, so remember it like that. And then you have hepta as 7. Hepta is also called septa, and you must know both of these. And we this will also be useful later on, the 7 hepta and septa later on when we learn organic nomenclature. And then guys, 8 is octa, 9 is nona, and then 10 is deca. So guys, you should know this numbering for doing the covalent compounds. So now guys, as I said before, let's take two examples. We'll take CO and CO2. So guys, you all know this is called carbon dioxide. So you can basically tell what we did was carbon stayed as carbon, oxygen became oxide, and then you put the di in the front. Now, what is this thing called? You have one carbon and one oxygen. This thing is called carbon monoxide. So yeah, this is the toxic gas we never want to inhale. So carbon monoxide. You guys notice that when you have two oxygens, we use di. When you have one oxygen, you said mono. But in the case, and if you remember the previous example we did earlier, P2O5, this was diphosphorus. What I'm going to ask you is to figure out what difference do you see in all these three names? Like, what do you find surprising? Diphosphorus pentoxide. Like, think about the prefixes. Like you see, this is monoxide, dioxide, pentoxide. All that makes sense because you have one oxygen, two oxygens, and five oxygens. But did you notice, guys, that for the first one, when you have a 2 here, you use di. That makes perfect sense because 2 is di. But when this guy was 1, this is 1 carbon and 1 carbon, we did not use mono. So guys, this is one extra rule that you need to remember. So like you can see, you used mono for the second atom, but for the first atom, you never used mono. So guys, for prefixes, every time you're going to show me the prefix for the first or the second atom. So the idea is, for whether it's first atom or second atom, you will always use a prefix, except when the first one is mono. So when the first atom is mono, don't use prefix. So don't use the prefix mono. Don't use prefix mono. So no prefix required. But when the second atom is 1, then you are saying mono, okay? But for the first one, you never say mono. But if the first one is 2, you're going to use di. If the first one was 3, you are going to use tri, but not mono, okay? So if I ask you this, PCl5, what are you going to call this guy? This will be called monophosphorus or just phosphorus? This will be called just phosphorus. So phosphorus, and when you have 5, that's called pent. And this is Cl, and Cl is chlorine. So can I say pentachlorine? No, you say pentachloride. So one modification you're doing is you're adding IDE. The second thing you're doing is adding a prefix. And you do not add a prefix if the first one is just one. Okay, so if you remember the whole thing, you will understand how the nomenclature for ionic compound for the covalent or molecular compounds work. Again, it's actually if you see, it's the easiest to name molecular or covalent compounds. It's more complex to name ionic compounds because you have to struggle with the charges. Here in covalent compounds, there is no chart, so you never have to look at the periodic table to find out the charge. Now, guys, what we're going to do is we're going to do one more example, and this is like your test question, okay? By test question, I mean you're gonna test yourself with this example, and you will tell me what should this be called. So V2O5. So 2 vanadiums and 5 oxygens. Can you give this guy a name? So pause the video, take a moment, and try to name this thing. Okay. Now, when you come back and you try to see this answer for this, ask yourself a couple of questions. If you call this divanadium pentoxide, that's wrong. Why is that wrong? Because you're thinking I have 2 vanadiums, 5 oxygens, it pretty much looks like this, P2O5. So this thing should be called divanadium pentoxide, but guys, that name is wrong. Why is that wrong? Because you did not ask yourself, is V2O5 ionic or covalent? What is this, guys? If I ask you, is this ionic or is this covalent? What is it? What do you need for that? You need to know whether they are made up of metal, non-metal, or non-metal, non-metal. So ionic is metal plus non-metal. Covalent is non-metal plus non-metal. And based off that, you're going to pick whether rules for covalent, which is prefixes, and or the rule for ionic, which is type 1, type 2, but no prefix in both the cases. So vanadium and oxygen, where are they? Vanadium is sitting here, a metal. Oxygen is sitting here, non-metal. That means it's ionic. It's not covalent. So can we use a prefix? No, we cannot. You cannot say divanadium pentoxide because you cannot use prefix. So since it's ionic, you need to ask yourself one more question. So guys, always ask yourself these few questions. The first question is, what kind of compound is it? Compound type. Is it ionic, molecular, or acid? We have not learned acids yet, but you should always ask yourself these 3 options. Once you decide what is it, then apply the rules. Apply rules, and if there's a need to categorize this further, you do that as well. Okay. All right. So V2O5 made up of metal and non-metal. So we decided it's ionic compound. Then you ask yourself, because ionic, you got 2 types, type 1 or type 2. What is this, guys? Is this type 1 or type 2? What do you guys think? V for vanadium. And vanadium, see, metals is what decides type 1, type 2. Don't look at oxygen to ask type 1, type 2. Look at vanadium. So vanadium is sitting here again, and this is type 2. Why type 2? Because we don't know the charge from periodic table. So this guy is type 2. So it's type 2, that's what we concluded. If it's type 2, guys, what was special for type 2 we always need? Parentheses. And if we need parentheses, guys, what does that mean? That we're going to need the charge of the vanadium. So now, guys, pay attention to this one, okay? This is a little more advanced example. So V2O5, we know the partial name, not the complete name, but the incomplete name. We know this guy is going to be vanadium, parentheses, oxide. Please don't say it pentoxide. Even if you're dying to call it pentoxide, don't call it pentoxide because it's not covalent compound. Vanadium oxide. What goes in parentheses, guys? Can you remind me what goes inside the parentheses? It's the charge of vanadium. Do we know the charge of vanadium from the periodic table? No, we don't. So we need to look at the formula. The neighbor is going to tell you the charge of vanadium, of the of the metal, type 2 metals. So V2O5, how do you find out the charge? Remember this? You have to divide your molecule into two halves. Where do you start, left or right? Always from the right-hand side. You ask yourself, oxygen is how much charge? Oxygen is -2 charge. We know that from the periodic table. And we have 5 of them. So -2 times 5 is -10. Why are we doing this step, guys? Because we want to find out what is the charge on the left-hand side. See, 5 oxygens are -10 charge total. Okay, each one is -2, 5 of them -10 charge. So if I ask you left-hand side is going to be how much, you will say it's +10. So you pick the same number, but the opposite charge, because this side is negative, this side is negative, this side is positive. So +10. Now, can you put +10 here? No, you cannot. Because the charge of vanadium has to be this single atom. It has to be per atom. So guys, just to make sure you understand this, you must put the charge per atom. Okay, so vanadium is going to be how much charge? See, it's +10 for 2 vanadiums, so each one is going to be 10 divided by 2, which is going to be +5. If that does not make sense, guys, think about this. You have 2 vanadiums and they have total $10. So each vanadium has how much dollars? So each one is $5 because you got 2 vanadiums, total $10, each one got $5. Okay, so you put 5 here, and for 5 you put the 5 symbol like that. So this is the final answer, vanadium 5 oxide. Okay, so guys, V2O5 name is not divanadium pentoxide. It's vanadium parentheses 5 oxide. Now, just in case you're wondering, how come just by looking at this, we can tell this formula is going to be V2O5. So let's do that as well. Let's assume you don't know this formula. So let's make that disappear, okay? Let's go from this name to the formula and see if this works out. So we don't know any of this, okay? All what we are given on the exam is this vanadium 5 oxide, and you have to give me the formula for that. So from name to formula, vanadium oxide, vanadium 5 oxide, what you do is you first write down the symbol, because in the formula, you know you got symbols, right? So vanadium is V, and oxide is O. Now, since this is ionic compound, to get to the formula, you guys remember the calcium chloride formula that we in the very beginning did? Let's look at that example. So when I gave you that I have calcium chloride, what did you do, guys? For calcium chloride, you first wrote down the symbols and then you put down the charge, and that's how you got the formula. So you have to do the same thing here. So for vanadium 5 oxide, you cannot just write VO and that's it, not that. So you have to write the symbol along with the charge. So vanadium is how much charge? Do we know that from the periodic table? No, that's why you're given that right here, vanadium 5. So vanadium is +5. How do I decide plus? Because it's a metal, so positive. And then you got the oxide. Oxide is how much charge, guys? Oxygen is -2. Again, how do we know? We know oxygen is -2 from the periodic table. Vanadium we didn't knew, but we were given in the name that it's 5 here, right here. So V is +5 and O is -2. Now you can simply do the crisscross. So V got number 2, oxygen got number 5. Your answer is V2O5. You see how from vanadium 5 oxide, you went to the formula V2O5.